So we've talked about getting to the moon, exploration of the moon. So let's talk about the actual parameters of the moon itself. Physically, we know the moon is about a fourth diameter of the uh, Earth. Well, that means that if you draw that to scale, it means you fit more than 4 moons inside Earth because you can fit it in all different directions. So Earth is considerably larger than the moon and very far away. As we said before, you rarely actually see them drawn to scale. So these two pictures here are drawn to scale in terms of size. Up here, they're drawn to scale both in size and in distance. So you can see that the moon really is a very far distance away from us. So even though it's the closest of the permanent celestial neighbors, it's still quite a ways away. And so that means it was really a big deal trying to get to the moon. Moon is so far away, it takes light about 1.26 seconds, a little bit over 1.25 seconds to get there. So the graphic at the bottom shows a beam of light going towards the moon and how long it takes to get there. If you listen to recordings of the Apollo missions to the moon, Mission Control would sometimes ask a question, and as they're starting to ask the questions, the astronauts on the moon would start saying something. It's not that they were rude and interrupting. They just the question that Mission Control was starting to ask had not gotten to them yet, and their question was already on the way back towards Earth when they started talking, and so they occasionally would talk over each other by accident. And again, sometimes Mission Control would ask them a question, and then several seconds would pass before they got an answer. That's not because they were thinking about it. It means that it took a while for the question to get there, and then they had to respond to it, and it took a while for the answer to get back. So you would expect, just imagine just a half-second reaction time that you ask a question, you're not going to expect an answer back for about 3 seconds. Average distance to the moon is a little over 250,000 miles. It is an elliptical orbit, ranges from 363,000 kilometers to 405,000 kilometers with a mean eccentricity of 0.05. It's got an orbit that's tilted with respect to the ecliptic by a little bit less than 7 degrees. Now, that's actually significant because of all the other moons of all the other planets, the main moons typically orbit right over the equator. Our moon doesn't orbit the equator, it orbits very close to the ecliptic. Just a few degrees from the ecliptic is, that's considered pretty much along the ecliptic because the planet orbits themselves are within a few degrees of the ecliptic. So that's significant in that its orbit is considerably different from the orbits of the other moons. Well, the other thing is that our moon is huge. Mercury has no moons, Venus has no moons, Mars has 2 little tiny things that are just a few miles across that are really asteroids, probably that got caught in Mars's gravity. Earth is the only one that actually has a legitimate moon, and our moon is about the size of the moons of the gas giants. So that raises some interesting questions here about our moon. And so that makes our moon quite different. Now that turns out to be very important because, as we know, the moon is actually changing the rotation of the Earth. If the moon were not there, Earth would rotate quite a bit faster than it currently does, possibly up to 6 to 8 hours a day. Well, that would have dramatic, huge impact on the climate of the Earth. The moon's tidal basins are part of what is believed to be permitting life to go from the oceans to the land. That interface in there was very important. And so we'd still have tides, obviously, from the sun, but nowhere near as big. And so the moon has had a dramatic impact on Earth, and so the question that we ask is, well, why is our moon so different from the other moons? Because without it, we wouldn't be the way that we were. Moon does have an elliptical orbit. These 2 photographs were taken, and I think I've shown these to you before. One is at perigee, one at apogee. So the perigee is the closest the moon gets to Earth. The apogee is the farthest it gets from the Earth. So this does show the eccentric nature here. If you get a full moon at perigee, the media often has taken in recent years to calling that a supermoon, though that's not a term that astronomers started using up until the media started using it just a few years ago. Apogee, that's the smallest moon there, and I don't think they have a special name for that. Physical characteristics of the moon. As I said, it's a little bit over a quarter diameter of the Earth. Okay, so it's very little oblateness. Earth, if you measure from North Pole to South Pole, is a bit different, a bit less than across the equator. For the moon, there is only a tiny difference between the diameter across the equator and the diameter from pole to pole. So the moon is very much closer to a sphere than is Earth. In mass, the mass of the moon is quite a bit less than that of the Earth. So the moon is only about 1.23% the mass of the Earth. So just 1.25% of the mass of the Earth. Now think about it. It's about a quarter of the. It's about 1/4 of the diameter. So you would expect it to be quite a bit less in mass, because that means, 1/4. So, 1/4 one way, 1/4 the other way, 1/4 the third way. So 4 cubed is 64. So that would suggest that the moon would be expected to have 1/64th of the mass of the Earth. And in fact, it's a little bit less than that. Density is less. The average density of the Earth, remember, was close to 5.5 grams per cubic centimeter. The density of the moon is about 3 1/3. That's about the density of the rocks for the crust and mantle of the Earth. So, if the moon has much of a core, that would have made that a much larger number. So this suggests the moon doesn't have a very big core.